So friends, we had started this concept talk series, and in the first video of that we had discussed about the real numbers. To understand what the real numbers are, if you haven't watched that one, I would request you to go there and watch it to understand what the real numbers are. In that series, today we are going to start with the second concept talk series. In second, we have chosen the topic called polynomials. Because for any class, no matter in which class you are, starting from your class 6th, you should know what the polynomials are in order to understand the algebra well. So, we are just going to study what the polynomial means, what is the degree of a polynomial, how do we write it in standard form, and how do we classify the polynomials, means what are the different types of polynomials and on what basis are the polynomials classified, terms associated with that. So first of all, in order to understand what the polynomial is, you must know two terms. Which two terms? First of all, you should know what is a whole number, and second thing, you must know what's a variable. Whole number, as we discussed in first concept talk series, whole numbers means all the positive integers and 0. All the natural numbers and 0. That means 0, 0, 1, 2, 3, 4. Whole numbers means the numbers which are either natural numbers or 0. Simple. Variable like x, y, z. Variable means something whose value varies. Something which is unknown to us. That is the variable. Now, in order to, if you know these two things, now you should know what is polynomial. So a polynomial is basically an algebraic expression. Look, it is basically an algebraic expression. Algebraic expression means any expression having the variables. But only condition is that exponent of variable is a whole number. Exponent of variable is a whole number. Let's explore this first. That what does it really mean? If I say x square plus 5x plus 2. Look, this is a polynomial. This is an algebraic expression. If you look carefully, it consists of three terms: x square, 5x and 2. And all these three are added to each other. In this expression, variable is x. Its exponent is 2. Here variable is x. Its exponent is 1. Here variable is 2. No, variable is not 2. 2 is a constant. Variable, I can write it as x to power 0. Because you know, we in general language, anything to power 0 is 1 in general. Not absolutely correct in maths. So x to power 0 is 1. So I can write 2 times 1 is 2. So it is an algebraic expression. So any algebraic expression, it may be. What you have to look? You have to look for the exponent of variable only. Nothing else. I'm not concerned what the exponent of this number is. Not at all. I'm just concerned with exponent of variable, and that must be a whole number. If it is not a whole number, I cannot call it a polynomial. See, let us understand it. So, here, what's the exponent of variable? X is the variable, its exponent is 2. X is the variable, its exponent is 1. X is the variable, its exponent is 0. 2, 1, 0, are all these whole numbers? Yes. So, it is a polynomial. So, in order to understand what the polynomial is, you must simply look at the exponent of variable. I'm emphasizing again, we are not concerned about exponent of constant. If I say x plus root 2, Is it a polynomial? So I will look for the exponent of variable. Variable is x here, so its exponent is 1. 1 is a whole number. Root 2. Root 2 I can say it is 2 to the power half multiplied by x to the power 0. 0 is a whole number, half is not a whole number. But we are not bothered about it. 2 is not a variable. So whatever the exponent of 2 is, it doesn't matter for me as far as the word polynomial is concerned. So I will say yes, it is also a polynomial. Correct? One more example, let me say x plus 1 over x. Is it a polynomial? So you have to look at the exponent of variable again. So what is that? If you see, what is the exponent of x here? Common sense, it's 1. What is the exponent of x here? Don't think it is 1 over x to the power 1. You think it like it is x to the power minus 1. Correct? Is minus 1 a whole number? No. That's why this is not a polynomial. So point is, polynomial means an algebraic expression where we are concerned with the exponent of variable, and that must be a whole number. That's only thing. For example, I have x plus root x. Is it a polynomial? Exponent of x is how much here? Thought? It's 1. What's the exponent of x here? Half. Is 1 a whole number? Yes. Is half a whole number? No. It means this is not a polynomial. Just you have to look for the exponent of variable to see or to find whether it is a polynomial or not. Let's understand a few examples here. So which of the following are polynomials? So what I will do? I will just try to find out what is the exponent of variable. I am not concerned with the numbers at all. Variable is x here. Exponent is 2 and 1. They are real numbers. So answer is yes. Here variable is only y. This is root sign on 2. There is no variable here, so I am not concerned with that. This is 2 here. It's a whole number. So yes. 3t, it's 1. It's a whole number, but problem is here. Root t means it is indirectly t to the power half. And half is not a whole number. So this is not a polynomial. If you look here, it is y plus 2 over y. So y is okay, y to the power 1. But 2 over y means I can say it is 2y to the power minus 1. Minus 1 is not a whole number. So it is not a polynomial. And if you look, x to the power 10, 10 is a whole number. Y to the power 3, 3 is a whole number. T to the power 50, 50 is a whole number. So yes, this is a polynomial. Look at, first thing you look at variable, then you look at its power. If that is a whole number, it is a polynomial. That is the simple criteria you have to look. Now, after understanding what is a polynomial, we should know the terms of polynomial. Look, a polynomial is just an expression. It may have just one term. It may have 2 terms, 3 terms. Terms means whichever portions are actually connected by addition or subtraction. That means the portion of the expression which are connected by addition or subtraction. For example, if you look here, 9x square y, all these are multiplied. So this is one term. And this is another term. So I will say this polynomial is just 2 terms. If you look here, 3x to the power 4, this is one term. X square, it's the second term. Minus 5x, it's the third term. And 9 is the fourth term. So this has 4 terms. So terms of polynomials are just connected by addition or subtraction. If I say x multiplied by y, it's just one term. These are not 2 terms because x and y are not added or subtracted. But if I say x plus y, these are 2 terms. While xy, it is just one term. So terms are separated by addition and subtraction. Second thing you must know here is that in every expression or in every polynomial, every term, term has two parts. Term itself has two parts. One part is called coefficient part. Coefficient part or constant part you can say. While other part, x square y for example here, that's a variable part. Because later on you must know, we will study the terms like terms and unlike terms. Like terms means those terms which have same variable part. We are not concerned with constants again. If there are two terms having exactly same variable part, they are called like terms. So here, so every term has two components, constant and variable. Even this one, if you look at plus 3, you can say, me sir, this is just a number, so it's a constant. Where's the variable? But I can hypothecate in my mind. I can say, okay, it is 3 times x to the power 0. What's the trouble? So it is, even 3 itself is a polynomial. Though you can say it doesn't have any variable. It has. I can say it is 3 multiplied by x to the power 0. And x to the power 0 is 1. So every term has a constant part and has a variable part, and these terms are separated by addition or subtraction. Okay, so then the next thing you must know here is degree. So many times the word degree or even sometimes order that comes into picture because it determines various characteristics of a polynomial. So what do you mean by degree? Degree again is used in two contexts. One, degree of the term of polynomial. Other is the degree of polynomial itself. So let us first talk about degree of a term of polynomial. If you look here at this polynomial, which I have written here in blue color, how many terms this polynomial has? If you count 1, 2, 3, 4 and 5. It has 5 terms. In every term, you look at what is the exponent of variable. In every term, you look at what is the exponent of variable. So that will be degree of that term. So if it is x to the power 5, so its degree is 5. It's x to the power 3, its degree is 3. It's x to the power 2, its degree is 2. 5, technically it is 5 times x to the power 0, so its degree is 0. X to the power 1 here, so its degree is 1. So degree of a term simply means whatever the variable there is, its exponent, if there is only one variable. But if there are two variables, like if I say x, y plus 1, then I can say degree of this. Now there are two variables here, x and y. Its exponent is 1 and 1. Then you have to add those two exponents. So 1 plus 1 is 2. So its degree is 2. Its degree is 0. If I say you this is a polynomial x to the power 3 y square, what is the degree of this? 3 plus 2, it's 5. So if there is only one variable, then you have to just look at the exponent or power of that variable. If there are 2 or more than 2, in multiplication, you have to just add up all the powers. So that explains what the degree of the term of polynomial is. Look at this other one. What's the degree of each term here? X to the power 8, so its degree is 8. X to the power 3, so its degree is 3. X to the power 1, so its degree is 1. Here, x to the power 0, so its degree is 0. So that is the concept of the degree of term of polynomial. Then what is degree of polynomial itself? For that, first step is you look at the degrees of all terms. If I ask you what's the degree of this polynomial, so you will look at all the degrees here. Every term, 5, 3, 2, 0, 1. Which is the highest degree? That is called the degree of polynomial. First you calculate degree of each term and then you look at which is the highest among them. That is called the degree of the polynomial. It looks like a bit of boring concept right now, but as we proceed further, you will come to know that this degree is very important. It determines the shape of the graph. If we draw this polynomial in the form of a graph, later on perhaps we will come on those things too in the concept talk series itself. But it's a very important thing. What's the degree of this polynomial? Degree of this term is 8, this is 3, this is 1, this is 0, so its degree is 8. So you have to just look at highest degree term, that's all. So that is about the degree of the polynomial. So I hope you might have understood this. Then we should know about standard form. Usually, if I write 5 plus 8 or 8 plus 5, mathematics, they mean the same thing. If I write x plus 1 or 1 plus x, they mean the same thing. So that is not the issue. But in polynomials, usually we write them in the decreasing order of their degree. Usually we write them in the decreasing order of their degree. That means first we write this term, then we write this term. We usually avoid this way, and that form is called standard form. Standard form means you write the polynomials in such a way that all the terms are written in the descending order of their degree. All the terms are written in the descending order of their degree. Let us have an example. Is this in standard form? If you look at degrees 5, 3, 2, 0, 1. Are all these exponents or degrees in descending order? No. So if I write it this way, first of all, biggest degree term, then next degree term, then next degree term, then this one, and then this. So that now if you look at degrees, they come in descending order. So now we call this thing, this polynomial, as in the standard form. So standard form simply means descending order of the power or descending order of the degree of each term. So I hope this might have been clear. So when you write something in the standard form, like we did here in the previous slide, the first one is called leading term. The first one is called leading. This is called leading term, and its constant part is called leading coefficient. So I think this is the first term, is the leading term, and its number multiplied to it is called leading coefficient. So I hope this is clear now. So now we have to study about how these polynomials are classified. So basically polynomials are classified in two different ways. One is on the basis of number of terms, how many terms a polynomial has. Other is on the basis of their degree. Let us first come on the number of terms. So a polynomial may have any number of terms, 1, 2, 3, 4, 5, 6, 7, 8, 10, 20. In general, we use just these three words. If there is a one term, we call it monomial. Two terms, we call it binomial. Three terms, we call it trinomial. And afterwards, we don't use these specific terms. We generally say it's a polynomial. One term means if I say x. Even if I say x. If I say 7x square. Or I say minus x to the power 5. All these are monomials because they are just one terms. If we go with the two terms, for example, x plus 1, maybe 2x minus 1, maybe 5x plus 7, maybe x to the power 3 minus 1. All these are binomials. All these are binomials because they have two terms. So that's a simple words. You can easily understand. Trinomial means having three terms, like x square plus 5x plus 7. Like 3x square minus 7x plus 1. Maybe x to the power 10 minus 6x to the power 5 plus 3. It can be anything like this. 1, 2, 3 terms, so it's a trinomial. Similarly, it has 4 terms, it's called tetranomial. But in general, after 3 terms, we use the word polynomials. So this is a simple one classification on the basis of number of terms. There's another classification of polynomials that is on the basis of the degree. So we have just studied degree of polynomial. But what we studied that? The degree of the highest degree term. Correct? So if that degree of polynomial is 0, we call it constant polynomial. If degree of polynomial is 1, we call it linear. If degree of 2 is we call it quadratic. If degree is 3, we call it cubic. If degree is 4, we call it quartic. In some of Indian textbooks, you will find a word called biquadratic. That's also okay. If degree is 5, it's called quintic polynomial and so on. Even if you know up to this point, it's usually good to go. So, degree is 0. For example, if I write 5, it's a polynomial whose degree is 0. So, this is a constant polynomial. If I say where k belongs to a real number, this is a constant polynomial. So, any polynomial whose degree is 0. So, that is a constant polynomial. If I look for linear means degree is 1, like 3x, like 3x plus 2. So, this is a linear monomial, this is a linear binomial, correct? It can be like 7x minus 1 or minus 7x minus 1, doesn't matter. This is also a linear binomial. So, these are the linear polynomials. Quadratic means their degree is 2. Quadratic means their degree is 2. 2 degree can be like 5x square. So, this is a quadratic monomial. If I write 7x square minus 7x, it's a quadratic binomial. But if I write 7x square minus 7x plus 1, it's a quadratic trinomial. So, both the classifications are coming together to giving rise to a single name. Same way, if degree is 3, that's a cubic polynomial. Degree 3 means like if I say 7x to power 3. Now it's a cubic polynomial, it's a cubic monomial. If I write 7x cube minus 1, it's a cubic binomial. I can write 7x cube minus x square plus 1, it's a cubic trinomial. Similarly, there can be cubic tetranomial too, like 7x cube minus 6x square plus 5x plus 1. So, all these are cubic polynomials. If degree is 4, it's quartic or biquadratic polynomials. For example, if I say power 4, maybe 6x to power 4. So, its degree is 4, so it's a biquadratic or quartic monomial. Similarly, if I say 6 to power 4 plus 1, it is a quartic binomial and like that. So, polynomials are classified on the basis of two criteria. One, on the basis of number of terms, how many are they? Second, on the basis of degree. If there is one term monomial, two term binomial, three term trinomial and so on. For degree, if it is 0, constant, 1, linear, 2, quadratic, 3, cubic, 4, quartic and so on. And then you can combine both these classifications. So that is the basic concept associated with the polynomials. So what we studied today, that polynomial is an algebraic expression where exponent of variable is a whole number. Then it may have different terms. All the terms are connected by addition or subtraction. Every term has one constant part, one variable part. Then every term may have its own degree, that is the exponent's variable, variable's exponent, variable's exponent. And if there are more than one variable, then adding their exponents. That's the degree of the term. The degree of polynomial itself, you look at the degree of all the terms, whichever is highest among them, that is the degree of the polynomial. Then you write a polynomial in the standard form. That means the first term of highest degree, lower degree, lower degree, lower degree, means you write all the terms in the decreasing order of their degrees. The first term, that is called leading term, and its constant part is called leading coefficient. Whether leading coefficient, it's positive or negative, that will also be very important factor in determining its graph later. And then we studied that these polynomials are classified either on the basis of number of terms or on the basis of their degree. So that is in nutshell a little bit knowledge you must know to start with polynomials. I hope you might have understood the concept well. If you really enjoyed it, please like or comment whichever improvements or which other topics would you like to know. And if you enjoyed it, please like it, subscribe it and share it with your friends or anybody who are interested in mathematics, because these topics are for anybody who who has a bit of interest in maths, and definitely they are must for anybody who is studying mathematics from class 6 to class 12. I hope you enjoy it. Thank you for watching.